Warm greetings from TNV Academy. Today I am here to discuss with you all about a very exciting topic, which is risk-based inspection. This term is widely heard and used across manufacturing industries nowadays. So before we start our discussion, let me tell you about the key takeaways of this session. At the end of this session, you will be able to understand what is risk-based inspection. What are the objectives of risk-based inspection? Critical factors of risk-based inspection. How does the risk-based inspection work? Benefits of risk-based inspection. And the last one is where risk-based inspection are used. So let's start our discussion and talk about what is risk-based inspection. The risk-based inspection (RBI) was introduced by the American Petroleum Institute (API) as API PUBL 581. It had three primary goals. Define quantity and rank the risk of process equipment failure in order to target the most essential components in a process plant. Reviewing safety, environmental and business-related risk in an economical manner. Reducing the likelihood and consequence of failure by allocating inspection resources to equipment carrying the high risk. The major objectives of the RBI is to provide the groundwork for managing risk through methods, coverage, and frequency of inspections. Since this entire course of inspection works on the basis of risk, hence it could occur from the equipment, operator, or even the equipment. One big change to this new edition of publication is the definition of an application boundary. Fixed equipment in refining, petrochemical, chemical process, plant and oil and gas production facilities. International engineering standards and practices fall under the following codes. API RP 580 Risk-Based Inspection. ASME PCC 3 Inspection Planning Using Risk-Based Methods. RMIAP Risk-Based Inspection and Maintenance Approach. Risk-based inspection (RBI) is an optimal maintenance business process used to examine equipment such as pressure vessel, QOC, quick opening closer, doors, heat exchangers, and piping in industrial plants. RBI is a decision-making methodology for optimizing inspection plans. The RBI concept lies in that the risk of failure can be assessed in relation to a level that is acceptable, and inspection and repair used to ensure that the level of risk is below that acceptance limited. It examines health and safety, environment (HSE), and business risk of active and potential damage mechanism (DMS), and assess and rank failure probability and consequence. This ranking is used to optimize inspection intervals based on site acceptable risk levels and operating limits, while mitigating risk as appropriate. RBI analysis can be qualitative, quantitative, or semi-quantitative in nature. Let us now talk about the objectives of risk-based inspection. RBI assists a company to select cost-effective and appropriate maintenance and inspection tasks and techniques to minimize efforts and cost, to shift from a reactive to a proactive maintenance regime, to produce an auditable system, to give an agreed operating window, and to implement a risk management tool. The objectives of RBI include: first one is to improve risk management result. The second one is to provide a holistic, interdependent approach for managing risk. Third one is to apply a strategy of doing what is needed for safeguarding integrity and improving reliability and availability of the asset by planning and executing those inspections that are needed. Fourth one is to reduce inspections and shutdowns and provide longer run length without compromising safety or reliability. The fifth one is to safeguard integrity. Sixth one is to reduce the risk of failures. The seventh one is to increase plant availability to reduce unplanned outages. The eighth one is to provide a flexible technique able to continuously improve and adapt to changing risk. The ninth one is to ensure inspection techniques and methods consider potential failure modes. Let us now talk about critical factor of risk-based inspection. There are two critical factors of risk analysis for RBI. First is the probability of failure POF assessment. There are two critical factors of risk analysis for RBI. First is probability of failure POF assessment, through which the company evaluates the likelihood of failure due to damage, deterioration or degradation. The second factor is the consequence of failure COF, that represents how much it would cost if particular equipment or machinery breaks down. Let's learn about these two critical factors in detail. Probability of failure POF in the RBI theory, risk comprises two parts. The first of which is probability of failure POF. It is defined as the chance that a particular asset will fail during a given time while operations are being carried out. This way, POF analyzes every possible area where damage can occur and from where the entire project has the potential to be compromised. POF is calculated for individual equipment by examining the potential damage mechanism which it may be susceptible to. Consequence of failure COF, the second part of the RBI theory, is the consequence of failure COF, which estimates failure consequences arising from faulty or damaged mechanism or part of a system. The purpose of the COF is to categorize assets based on the potential failure significance. These are categorized in three groups: health and safety impacts, environmental impacts, and business impacts. The overall risk is then defined as a combination of these factors, probability and consequence. We will now move forward and talk about how risk-based inspection works. In the first step of a risk-based approach, inspectors have to collect information about the organization's equipment and machinery. They should focus on aspects like the type of potential damages, error, frequency, rate. They should focus on aspects like the type of potential damages, error frequency rate, or the place where malfunctions occur. There are three basic approaches to data collection for RBI. Qualitative. Take into consideration descriptive data based on the judgment and experience of inspectors. Quantitative. Inspectors base their assessment on statistics and probability. Semi-quantitative. Organizations use both approaches, qualitative and quantitative, in the risk analysis. In the next step, companies proceed with the risk analysis itself, taking the probability POF and consequence of failure into consideration. After this assessment, companies see which inventory can pose the highest financial and safety risk. Therefore, organizations can focus on these assets and flexibly adjust their inspection and maintenance plans. The overall goal is to mitigate the number of critical failures by optimizing maintenance activities for high-risk equipment and saving resources on low-risk assets. We will now discuss and learn about the key benefits of risk-based inspection. There are several advantages to risk-based inspection over reactive approaches. Improving risk management by regular risk analysis, assessment and its mitigate. Minimizing downtimes by preventing critical malfunctions. Saving money by developing a more efficient inspection plan and reducing unplanned outages. Optimizing workforce resources by eliminating unnecessary inspections. Uses of inspection sources in a more economical way. Better visibility into the health of your critical assets. Reduction in the number of failures. Improvement in the reliability and efficiency of your equipment. Identification of operational risks that are associated with equipment degradation. Planning of maintenance activities while avoiding unnecessary shutdowns and delays. compliance of used equipment with the environmental as well as the safety regulations. Regular monitoring of equipment will lead to lesser technical malfunctions. And finally, let us now discuss where risk-based inspections are used. In the API RP 581 documentation, API defines for which areas is the RBI methodology intended. It specifies quantitative procedures for fixed equipment in refining, petrochemical plants, chemical processes plant, oil and gas production facilities. The principal focus on equipment like pressurized fixed equipment, pressure vessels, piping, tankage pressure relief devices, and heat exchanger tube bundles. So, we have now come to the conclusion of this session. In case you have any queries on what we have discussed today, please put them in the comment section of the video and we will be really happy answering them. Till we meet next in another session, it's best wishes from TNV Academy.